Here is the Laplace table that you see. Just to give you an example, okay, this is actually a unit step which is equal to 1. So this is a unit step. So these are the Laplace transform table, and with this side it's in S domain, and this side it's in time domain. Okay, so this is the Laplace table that we're going to use. So we'll be moving from sometime from times domain to S domain. This is what we call Laplace transform, and from S domain to times domain we call it inverse Laplace transform. So you should know that when we move from time to S domain, or from S to time domain, so this process we call it the Laplace, we call it Laplace transform. Okay, Laplace transform. And then the other one, from S to times domain, we call it inverse Laplace. Okay, so we'll be doing this. Okay, and sometime for you to move from S to time domain, so we have this condition. So from S domain to time domain, you need to check into the table. Okay, so you need to check into the table if you see the form. Okay, if the equation that is S domain, it's from, you can see it's similar to what we have in this table, then you're going to move straight to the condition that we get the other side easily. Now there is a problem if there's no any form like this into your equation. So that's why you see we're using partial fraction. We're using this partial fraction because if there's no we can find the form into the table. So just to make this one, just to get the table form by decomposition. So this is what we're going to do. So you'll see one example on this, how we do moving from S to times domain. And there is also this other rules that you should know. Okay, so, and then once you get your partial fraction, so let's just continue this. Once you get your partial fraction, then you get your equation into times domain. Okay, and once you get it into times domain, then what you do, we sometimes replace the value of t. So we're going to replace the value of t if it's given. Okay, if it's given by the instructor. This, for example, I can give you, for before we get to partial fraction, we add this form v out, and then after getting to the partial fraction, then we're gonna end up with v out of t, and then you're just gonna place, if there is another condition from here on, then you're going to replace the value of t. Now with this from times to S domain, we do have some other condition, some rules that you need to know, which is check firstly, before you move to S domain, you need to check for initial condition. Check for initial condition. Okay, this is the thing that you need to pay attention. If there's no nothing no information about the initial condition, then we're going to assume that the initial condition equal to 0 if there's no information about the initial condition. Okay, pay attention to this. So if there's no condition about the initial condition, we're going to assume that it's actually equal to 0. Okay, so we're not gonna mind switching straight. We're going to switch straight from times to S domain. Okay, and this is when you work with equation. Okay, and this is what I was going to show you. So okay, so and it's actually not on this section. I wanted you to emphasize of this. I'll give an example later on of when we have a initial condition, okay, and when we have to replace the value of t into an equation after converting it into times domain using Laplace. This is more for Laplace. Okay, what you see under here is what we're going to use for Laplace. So this is for Laplace, and then you're gonna get these two conditions, and this one is for the differential equation. Okay, or I can call it ODE. You need to pay attention to this rules. You need to check for initial condition when you convert from times domain to S domain conversion. Okay, you need to pay attention to that. But for Laplace transform, it's just on the final, you need to go for partial fraction first. If there is no way that you can get straight to the, you cannot find any form into this table, then you go straight for partial fraction, and then you go for, you replace the value of times if it's given. If not, you're going to leave the equation as it is, for example. So this is what you should know about Laplace transform and where we're going to apply these formulas. Okay, and this is where you see we're going to apply the partial fraction, because this form, the form that you see here, we can't find it into the table. So we don't have this form into the table for us to take the inverse Laplace. Okay, so we don't have this form into the table. If you check into the table, we don't have this form, so that's why we're using partial fraction. Okay, so if you check, we don't have that condition into this table. Okay, if you check that the one that I showed you, it was just equation similar to the one that I'm currently working on.